Hi folks, this is an introduction for the in-class work on ring modulation. It's about 10 minutes long, but I suggest you watch it. I'm going to explain what you're doing, exactly how, and then particularly exactly what your deliverables are for this project. Ring modulation, as you know by now, is amplitude modulation. This is standard VCA. It's the one that we have. All standard VCAs basically want to see a one quadrant positive voltage only signal into the control input. The signal inputs for a VCA can accept two quadrant or one. So they are AC coupled. You can put a full sine wave in and it will process it. You could also just put in positive voltage and it will be just as happy. So that's why you can use a VCA to input, say, the signal from an envelope generator, which is positive only, and then modulate the amplitude of that. When a one quadrant signal comes in here, it actually comes up to this attenuator. This controls how much it affects the signal, but what it does is it merges it with your initial gain setting. Anything coming in here is added or summed with your initial gain, and this goes down and controls how much of these come out of here. So that is how a VCA works. But with ring modulation, we want to be able to multiply two quadrants, two up here times two down here. That's why they call it a four quadrant multiplier. If you feed a two quadrant signal into a control input, it will only see the positive portions of the wave. So what you end up with is something called half wave rectification. It only sees and responds to the positive portions of the wave. Now, if your modulator going into the control input was in the sub-audio range, like an LFO, you would hear it going like that. But ring modulation is usually used with audio rate signals. So even though this isn't processing, a normal VCA is not processing the negative portions of the wave, because it's in the audio range, you're still getting amplitude modulation sidebands, which is why it can sound ring modish even when it's not. So what we need to do is we need something called full wave rectification, where we take the negative portions of the wave and flip it up so it's also positive. I'm going to show you how to do that manually so you can Frankenstein up a ring modulator when you don't have one. You're going to patch it up in VCV and then compare it to a real ring modulator. This is what you're going to do in VCV. You're going to take a plain sine wave audio carrier, blue is audio, feed it into a VCA, and also identically, same signal into two VCAs. Audio rate sine wave into two VCAs. Both audio outputs into a summing mixer. So far, so good. Then you're going to add an audio rate sine wave modulator. Notice it's red, meaning control voltage, even though it's audio. Going to come in here to VCA1. This will be responding to the positive portions of the wave. Then you're also going to mult this and invert it and process VCA2 with the inverted negative portions of the wave. So now it'll literally be going back and forth, but at the audio rate, but on the same carrier, merged here. Pause. This is what you're going to do in VCV. And then you're going to compare it to a real ring modulator. So the reason this is not real ring modulation is that ring mod means sum and difference without hearing the original modulator and carrier. So for instance, if your carrier was 500 hertz and your modulator was 300, a real ring modulator would only let out 200 and 800. This patch will let out 200 and 800, but also it will pass through the original 300 and 500. So you're going to hear ring modish behavior, also hearing the carrier and modulator. And then you don't have to do this in the lab, but I'm going to quickly show you. If you wanted to turn this into a real ring modulator, all you'd have to do is take the inverted modulator, feed it into the mixer so it cancels out the modulator coming through the VCAs, and do the same thing with the carrier. You would invert it and feed it in. The only thing to be aware of if you try to do this is that since you have two versions of your carrier, for instance, If you fed this in at the same volume, it wouldn't fully cancel it. This would need to be 6 dB hotter, or these would have to both be 3 dB down. Same with your modulator signal. Enough of that. Let's get to what you're doing in VCV. You're going to manually patch up what I just showed you, but without the, all the inverters going into the mixer. You'll be hearing the sum and difference signals and the original carrier and modulator. Then you're going to insert an actual ring modulator and compare it. These are your deliverables. There's two parts to the lab. One, you patching up stuff that I asked you to do, make some audio captures. Part two is you having fun and playing and making cool sounds. Part one, you're going to make a patch exactly as I show you. You're going to save your VCV patch. You're going to name it just like that. You're going to make an audio capture of it, 5-6 seconds. You're going to name the audio capture exactly the same thing. It'll have a different file extension, so I'll know what it is. Then you're going to add in the real ring modulator to compare the two and do the same thing. Save the patch, audio capture, same name. Then I'm going to take you onto the web and you're going to add another company's modules in, and you're going to add a different ring modulator and quickly compare them to see if it's the same or not. Save the patch, save the audio. So you will have 3 original patches following my tutorial, an audio capture for each, and these are 5, 6, 10 seconds. Then you're going to take those 6 files and compress them as an archive, named exactly like this. And all of your deliverable names are provided to you as a separate document. That's part one. Part two is you get to play. What you're going to do is take that whole patch and then using any combination of all those different ring modulation or modulation-ish sounds, you're going to be allowed to instantiate some effects. Nothing crazy. No disintegration. No granulation. No crazy stuff. A simple delay module and or a simple reverb module. Then you're going to program a bell sound. Probably getting ahead of myself here. You're going to program a bell sound. And then you're going to make an audio capture of it, named the same, with no effects. Then you get to turn on the effects and make a second audio capture with the effects. Then you're going to do that 2 more times. So part 2 will be 3 of your own VCV patches, Loisel Bell 1, Loisel Bell 2, Loisel Bell 3, VCV patches, and then 6 audio files. Loisel Bell 1A without effects, Bell 1B with the effects. So basically, here we go at the end. This is what I just said. So deliverables for part 2 will be your 3 bell patches and your 6 audio files. 3 dry, 3 with effects. You'll zip and upload these 9 files. Last name, CW-WK05, bell, archive. Final frame. Here is your final deliverable for the lab. 2 files, both zipped archives. Last name, CW-WK05 RM archive, and bell archive. So now go to the tutorial and let's get busy.